In this video lecture, we'll be solving this problem word search, which is a Leetcode medium problem. In this problem, we are given a m cross n grid of characters named board and a string word. We have to return true if the word exists in the grid, or if it doesn't exist, we have to return false. The word can be constructed from the letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter may not be used more than once. So we are given a grid of m cross n and a target string word. We have to construct the given target string from the characters of the board such that we can use adjacent characters, namely horizontally adjacent and vertically adjacent, and a character can be used at most once. In the input, we will be given a board of m cross n dimensions along with a word which we have to search in the given board, and in the output we have to return a boolean variable which is either true or false depending upon the existence of the word in the given board. The dimensions of the board may go up to 6 cross 6. So the largest board that we can have goes up to 6 cross 6, while the largest word that we have to goes up to 15 characters. And both board and word consist of only lowercase and uppercase English letters. So we do not have any kind of special characters or integers or integers. All we have are lowercase and uppercase English letters. So let's better understand the problem statement using an example. So here we have this board and the dimensions of the boards are 3 cross 4, and this is our word which we want to search in this board. How would I search this word in this board? So before moving on to the solution, let's see if this word exists in the board or not. Now the conditions for the problem are: the word may exist as a set of sequential characters in the board. So the characters in the word must be either horizontally adjacent or they must be vertically adjacent, and one character in this board must be used exactly once in the formation of our target word. So let's see. So in this particular example, you can see that A, B, C, C, E. This particular combination constructs our target word. You can see that the characters in this word which is there in the board are adjacent horizontally. Here A, B, C, they are adjacent horizontally, as well as they are adjacent vertically, C, C, E. And we are using one character exactly once. Fine. So it satisfies all the conditions of the given problem statement, and it also matches with our target word, and hence we conclude that the word exists in the board, and we return true for this particular test. Fine. So how can we solve this problem? What is the intuition to solve this problem? Let's discuss in the next. So let's discuss the intuition to solve this problem. So let's try to build a solution to solve this problem. We have this board of dimensions 3 cross 4, and we have our target word as A, B, C, C, E, D. We want to search if this word exists in the board or not. So how do we search that? The most naive approach is to simply brute force. So what do we mean by brute force? That is checking every single combination of the words possible. How do we do that? We have to use a backtracking approach to do so. So let's first traverse this matrix, or traverse each character of the given matrix. So first we start with A, and here we take another pointer which traverses this word. Now we want to first search for the character A in this given board. So we find such character at the very first cell of this matrix here. Fine. So this character of the word is matched. So we move to the next character. Now I want to match character B, and the condition is that I can move to adjacent cells of this already matched character, either to the left or to the right, up or down. So here I can move to the right and down. So I check if there is a character in any of the adjacent cells which is matching with this B, and here we find such character at the right cell. So we include this as well. Then I move my pointer to the next character because I have already matched AB. I want to find C in the adjacent cell of B. So I go to adjacent cells of B which are left, which are this right cell and the cell below it, and we find C here. Then I search for the fourth character, which is again C, and from this C I can move to right down in the previous cell, but I can see that I cannot move to the previous cell because the previous cell is already visited. So we have to handle this edge case. We have to handle this case or detail where we have to make sure that we do not visit a already visited cell again while searching for our target word. So I find my second C at the cell just below it. So I include this cell into my word search. Then I move to character E. I want to find character E in the adjacent cells of C, and I find such character in the cell just below it. So I find E here. Then I want to find D, and I search for D in all the four directions of E, and I find D and I find in the left adjacent cell of E, and I have exhausted my word string. That means I have found my word in this given board, and since I have found the word, I will return true right from here because I have reached the end of this word and I have found all the characters in the given board satisfying the conditions which are given in the problem statement. That is, they must be vertically and horizontally adjacent, one character must not be used more than once, and they must match with the word which we are given, and we find such string or word in our matrix, so we return true. So this is a brute force approach. We have to backtrack. Why do we have to backtrack to solve this problem? Because consider the case. Let's modify our board a little bit. So let's continue from this point. I have found my second C in this cell here, and now I want to find the next character, which is E. In the previous case, we didn't have E at this position. We have another character at this position. So we moved to the cell which is just below it, and hence I found my target word by finally moving to the character D. But in this case, let's say we move to this cell, which is the right cell of C. So I move to this cell. I include E into my word search. So I have found this much string into our board. Now I want to search for D, but I can see that in the cells which are adjacent to this E, we do not have D here. We have E in the cell just above it and in the cell just below it. So what do we do here? In this case, I can't leave this as it is. Rather, I have to unvisit this cell which I have already visited, which is E, and I have to explore another cell which is adjacent to C, which also contains E. So I unvisit this cell. This is unvisited. I come back to this cell here, and then I visit the cell just below it, which is this one, so that I can arrive at the right position. After that, the process continues. I move to the right cell. I find D, which is the last character of our word string, and hence I return true from here. Here I had to backtrack. That's why I have to use backtracking or a depth first search approach to solve this problem. Fine. So let's see the implementation solution which I discussed here. So this is the implementation for the given solution which I discussed in the previous slide. It takes in the given board B and the string W, and I want to search this W into this board B. I find the number of rows in the given board. I find the number of columns in the given board. Then I iterate over all the characters of the board, and I check if the first character of this string exists in the board or not. So here I find, whenever I find the first character in the board, in that case, so that can be a position where I may find my potential word. So I simply mark that cell as visited. So how do I mark that cell as visited? I simply put a dummy character at that position. In this case, I'm putting 1 here. So I visit that cell and I call this function solve, which is a recursive function or a helper function which is used to find if there is a valid word which exists in the given board starting from position 1 till len -1, where this len is the length of this word W. So I have already matched the first character here, and I want to match the rest of the character in the given board. Fine. If this function returns true, then that means I have found such word in the board, and hence I return true from here, and I unvisit that cell here. So that's why I'm storing this character in a temporary variable, so that I can unvisit that cell here such that, because there can be multiple occurrences of this character where I may find my potential word. Fine. So otherwise, if I do not find my word at any of such positions, then at the end I will return false. So this is the solve function. It takes in the coordinates of the cell which we have already visited, and the dimensions of the given board, and the index of the character of this word W which we want to match, while B represents the board. So if this index becomes equal to the size of the given target string, that means I have matched all my characters in the board and I return true right from here. Otherwise, these are the directional vectors or matrix. These are the directional vectors which will be used to traverse to the adjacent cells of I and J. Then I traverse the adjacent cells. So here I am moving to new cell from the cell IJ, and here I am checking if the new cell is a valid cell. So first I am checking if it is within the boundary of the matrix, if it is visited, or if the character at the new position is not equal to the intended character which I want to search, which is the character at this in position in this word. If it is the case, then I continue right from here because this is not the valid position. Otherwise, I visit this cell because I have found my target character. So here I am visiting that cell because I am assigning a dummy character at that position. That means I have visited the cell, and I will recursively call the same function for the new cell. So here I am passing the new cell, and here I am incrementing my index for the string W by 1 because I want to match the next character of this word. Fine. So if this function returns true, then that means I have matched the rest of the character or rest of the string. Then I will return true right from here. Otherwise, I will unvisit that cell. That means I have not found my word in the given matrix by following this particular path, and hence I unvisit the cell. So after that, I will return false right from. So why I'm returning false here? Because I've explored all the possible words in the given board and I haven't found a word in the board, and therefore I will return false at the end of the function. Fine. So this is how the function is working. Let's see the time and space complexity for this. Okay, so the time complexity for the given implementation is n cross m cross 4 raised to the power L, where L is the length of the word which we want to search. So why the time complexity is this? Because standing at any cell, we have 4 directions to move, and hence the search function or the solve function which we discussed can be recursively invoked 4 times, and hence the number of function calls, and hence it will give me 4 raised to the power L time complexity. While in the worst case, we know that in the worst case, let's say the first character of the target string is present in each cell of the board. In that case, this search function or solve function is invoked for all the cells of the matrix, and there are n into m cells in the given matrix or board. So that's why this factor handles that type of situation. So the overall time complexity becomes n into m into 4 raised to the power 5. While the space complexity for the given implementation is big of L, because in the recursive stack which is used, we may have L function calls, which is equivalent to the number of characters in the given word. Fine. So I hope you got the idea how we solve this type of problems. The solution is entirely a brute force or backtracking solution where we have to search for every potential word. So let's jump into the implementation part. So this is my solution class where we have our exists function which checks if the given word W exists in the board P, then it returns true, otherwise it returns false. And this is my solve function which takes in the coordinates of the current cell which we have recently visited, the dimensions of the board, the index of the character which you want to search, index of the character in this string W or word which you want to search in the board. So I calculate the dimensions of the given. I iterate over all the cells of the given board, and if I find my character at any position, so we are searching for the first character, then I visit that cell. So here I am visiting the cell by placing a dummy character at that position, and I call the function solve for that particular cell and to search for the next character. and to search for the remaining string. So if this solve function returns a positive value or a true, then I will return true from here, because that means I have found my word in the given board. Otherwise, I will unvisit that cell right here. Then, so if after checking for all the potential candidates here, I do not find my target word, then I return false from here. So let's see the working of the solve function. Since this is a recursive function, we have our first base case, which is simply like if we have reached the end of the word, then that means I have checked all the potential characters in the given board and they all have been matched, and hence I return. Here I declare a direction vector which will be used to navigate to the 4 adjacent directions of a particular cell I. Here I am iterating over all the adjacent directions of the current cell ij, and I go to the new cell and I check if the new cell is a valid cell, if it is within the boundary of the matrix, if it is not visited, and if it do contains the character which we are searching for, the character in this W string. In that case, I visit that cell and I recursively call my solve function for these new coordinates. So if this solve function returns true, then I return true from here. Otherwise, I unvisit that cell and check for the next adjacent cell. Fine. So if I find my character here, then I return true from here. Otherwise, if I do not find my, otherwise I will be returning false at the end of this function. Fine. So this is the implementation in C++. So this is the implementation in C++. Let's see the implementation in other languages. So this is the implementation in Java language, and this is the implementation in Python language. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to my YouTube channel and give your feedback in the comments below. I will see you in the next video. Till then, take care. Bye bye.